Now, we can go one step further with zk in that with zk, we can have a single operator, single node, build block, and send with that block to other shards a proof. And this proof, this cryptographic proof, can, with utmost certainty, guarantee that the things that they process over their shard are correct. And this is a massive unlock that allows us to go really horizontal in our scale. And this is why zk is such a sort of powerful or magical technology for the world of blockchain and blockchain scalability. When it comes now finally to zk-Sharding and to what we're doing with NIL, we internalize all of that complexity into protocol engineering, not social dynamics. In that the protocol itself, the architecture itself from the get-go is meant to be able to do this scale up, right? And we don't have to, as an application, you don't have to lobby to be included within our consensus set or be lobbied to be included as a shard, right? You simply deploy your application to the network and NIL handles the rest. And we think this is a user experience that can really differentiate NIL in a sea of fragmented rollups and political games.
One of the bad consequences that you have right now with Ethereum's rollup-centric scalability roadmap is that you have a number of layer 2, layer 3, and layer 4s that results in state fragmentation, and that in turn results in bad user experience. So this is one of the situations that drives a lot of users from Ethereum ecosystem to layer 1s like Solana. So today we are having a conversation with Avi Zurlo, the Chief Product Officer of NIL Foundation. NIL Foundation is an organization that is focused on deploying a unique roll-up architecture on Ethereum, which leverages zero-knowledge technology, a solution that could potentially solve the state fragmentation issue that Ethereum is facing right now. So without further ado, let's go into this conversation with Avi. Welcome to the conversation, Avi.
Thanks, Suraj. Pleasure to be here. Excited to dig into it.
Yeah, cool. But before we go into the details of the product you're building, could you please talk about your journey in the crypto space? What's your background? How did you enter the space? And what motivated you to take the CPO position of NIL Foundation?
Good question. Now, I'll start maybe from the beginning of what got me into crypto to begin with, just from a hobbyist perspective. And that was buying things online and having this magic internet money that allowed me to buy things I could have never bought anywhere else. And this was really fascinating to me. And kind of was my first touch in my, younger years. From there, I was an engineering student and wanted to understand these systems a bit better, and was really fascinated with, the Ethereum white paper when that came out, and a few of the alternative L1 blockchain designs, and followed along. And really, crypto was a hobby for me. In 2020, that hobby turned into a full-blown obsession, and quickly something that I needed to pursue it professionally full-time, because I was no longer doing my day job that I was being paid to do. I was, just deep into this space. And, this concept of a world computer was something that really drew me into crypto, that Ethereum had found forth, and understanding and actually realizing that there were applications being run over this world computer was so fascinating to me. And that these applications could inherit certain properties of that world computer in terms of censorship resistance and immutability and permissionlessness. So I joined Delphi Digital in the beginning of 2021, and had an incredible just shy of 3 years ago, and did early stage crypto investing, primarily focused on infrastructure. And in fall of last year, I joined NIL. And NIL is such an amazing organization. There is just an immensely talented team of engineers and researchers who've been building zk, for the most part, technology And over the last year and a half, I've actually been developing the L2, which is nil. And this is based on, as you mentioned, a novel protocol architecture called zk-Sharding. And it's a horizontally scalable solution for the Ethereum ecosystem. And we can talk a little bit more about that. But yeah, I love my job now. This was definitely the right decision for me. I love investing time, but the operating side, a lot of.
Yeah, if something like you started as a hobby becomes an obsession and you love it so much that you want to work there full time, it's a cool situation. But sometimes, I can imagine that being a CPO of such a ambitious project also comes with a bit of stress and workload, and hopefully you are managing with.
Yeah, you should ask my girlfriend how she feels about that. So, I mean, it's a lot of work. It's very different than investing. But it's very fulfilling for me. It's a problem space that I enjoy being in, and the pace of development and solving problems, and working with social dynamics that are truly so chaotic that you don't get as much exposure as an investor. All of that is all worth it, right? And ultimately, the thing that we're building towards at Nil Foundation, I have so much conviction in that I'm able to wake up, and even on days where it's like, oh God, like why did I do this? This is a bad decision. I can come back to product vision and know that we have a team that's really committed to that and feel excited about getting the day's work done.
Yeah, cool. And Nil Foundation has been in existence since 2018. So it's like a project that has been there since the inception of Ethereum's led to a roll-up centric roadmap. And being a CPO, the Chief Product Officer, what is the core thesis, would you say, of the product you're building? So what is the product? What's the core thesis behind that? And what is this single biggest problem that's solving?
Yeah. Good question. I'm going to try to distill it down into one line, and then we can talk about what that means. But I think the core thesis is global public blockchain cannot be processed through a single machine. And what I mean by that is, in the world of sort of modular versus monolithic, right? The monolithic world has tried to fit everything into a single machine, right? You have a validator node, full node, who takes, sort of the traditional tasks of processing and, operating a blockchain of execution, settlement, and data availability, and bucket it into one single machine, right? And the world of modularity was this great solution, as it said, okay, well, let's take each of these tasks and split it over multiple machines. And classically, we kind of had, 2 to 3 full nodes that are behind processing every block in the modular stack, right? We have a roll-up full node. We have, say, Ethereum for settlement, and say, Celestia for data availability, right? And this is a form of horizontal scaling, because we now tap into the power of multiple machines. And this was, I think, the brilliance of modularity. And actually, you now see the monolithic chain that I think I saw that. You may have to check me on it, but that Solana is now kind of looking to split execution and consent execution and data availability, right? And looking for this in terms of roles over separate validator work type node. And so you now see okay, well, we need more machine to power these blockchains. Nil takes it one step further. And core to Nil is zk-Sharding. So it's really zk-Sharding takes it one step further, which is, we've already gone modular, right? We've taken the 3 tasks and we split them over 3 full nodes. But can we access more machine? And the way to do that is sharding. And instead of splitting by tasks, we actually split by state, right? And now full nodes are only responsible for a portion of state, and we're able to scale orders of magnitude more than we would have been able to if we were under the constraints of a single machine.
Okay, so you align with the modular thesis, and you are trying to build a system that is not fragmented, but much more unified than what it is right now. So, for example, now using the layer 2 of Ethereum, it's a horrible user experience. Obviously, it takes away the magic that Ethereum was as a single atomic composable platform with different apps. So that layer 2 landscape really suffers from this composability problem. How exactly do you solve that problem? Or let's start from that. How are you going to solve that?
Yeah, this is a good question. And there's an important sort of asterisk in the attempt that we are trying to make to solve this problem, which is we are launching another L2, right? And every L2 that launches inherently introduces state fragmentation between, that L2 and others. But we fundamentally think this state fragmentation problem is not an interoperability problem, that it's a scaling problem, right? And that we need more scalable architectures that are sort of scalable from a first principles perspective. And we believe the best way to do that is implementing horizontal scaling techniques. That's why we choose the modular stack, and that's why we choose Sharding. What that means is we're able to add additional shards, add additional machines to the nil network without compromising fragmentation of state, in that any contract deployed to any shard within the nil network can arbitrarily call another. And this is a very important sort of feature for us when we think about like just system scaling at all, right? If we add a new rollup, and let's say we take and we won't call any name, but let's just we take a traditional rollup company today or stack, and we add a new rollup under this ecosystem. All we've done is created a new independent blockchain with the same brand, right? These things share no ability of calling arbitrarily state between the two. And so fundamentally, the notion of global state is broken. The other important piece that I think is more of an opinion, but in order for us to really have this true global notion of state and scale horizontally, we need to share in some sort of security, and most likely share in some sort of consensus, right? So I think this is a lot of the work that's being done with the shared sequencers and rollups, kind of heading in the right direction. But what we believe at NIL is if we start from the beginning, assuming that we need to have some sort of shared consensus, we can actually sort of bake that into the protocol much easier, right? And spin up these shards, look like independent blockchains, but share in some security resources and maintain the ability to arbitrarily call each other.
In that sense, like a contract on one shard can arbitrarily call a contract on another shard. So that is like atomically composable in that sense, right?
Well, atomically composable, that's an interesting, it's not necessarily true, right? And this is a point that has been a major pain point for sort of the design of sharded blockchains, right?
Yeah, exactly.
Because you are essentially splitting the state amongst these shards. When a shard communicates with another shard, you inherently have this async message passing, right? Now, there are a few ways that we can actually make this user experience more seamless, and we can mitigate the asynchronous sort of overhead that is baked into the network. One of the best ways to do this is actually to vertically scale each shard. And what that means is, vertically scale, we can make each full node that is managing more powerful, and more powerful in that they can access more hardware that the software is actually running over. And so we can increase the hardware utilization. And one of the really popular ways that this is being done is through, parallelized virtual machine. There's a number of other sort of optimization, like your sort of serialization, your read-write access. how you manage state in or memory in RAM or on disk. But these parallelized virtual machines have gotten a lot of sort of conversation going in the market these days. And what we can do is we can take these vertical scaling techniques and actually really push the throughput of a single shard. That's that a single shard is in and of itself super high performant, dare I say, Solana-like experience. But behind the scenes, we have this architecture that fundamentally will allow us to scale to a global size, right? Because that single machine, that single shard architecture will never, ever reach, sort of the fruition or the full manifestation or vision of, globally scalable world computers.
Oh yeah, got it. So in that sense, like each shard could have, there could be this high performant like shard, something like Solana, and there could be like a shard with a different, shards with different varying amount of vertical scalability in that sense. That's what you're saying.
Yeah. So this is a good point. Because folks have asked me, in conversations and talking to application teams and investors that, can you support different types of shards, right? Can you support, say, a shard that runs the SVM, and another shard that runs the EVM? And can you have shards, opt into different data availability layers? And can you have this heterogeneous sharding network? And it's certainly possible, but it may not be necessary.
Mm-hmm.
It's not something that we are going to launch with, right?
Okay.
The homogeny, right, of execution environments, we believe is actually efficient if you get the execution environment right, sufficient for 80, 90% of applications. So long as you can maintain reliably low transaction fees, security thresholds, and sort of performance in terms of processing speeds.
So that means it would be like a very optimized EVM, taking on the optimization that's being brought by all these platform. Like I was just writing something about Monad, for example. So they are bringing like a lot of optimizations for EVM, and so these innovations could be integrated to the execution environment that Neil is building.
Totally. And this is a super important point that we're taking a very opinionated approach about the sequence of problems to solve.
Yeah.
Right. Because we can't do everything, right? Monad is going to build a fantastic vertically scaled EVM based L1. I'm pretty sure of that. And it's going to be very quick, right? And it will be able to handle a higher throughput and so on. But we feel that when we look 5 years down the line, just 5 years, that eventually these designs that are constrained to fitting things into the window of a single machine are fundamentally going to break. And the important problem, while it's not obvious right now, is actually to solve for this horizontal scalability, to build a protocol architecture that can reliably scale out and add new machines, sort of new portions of state to this global network while maintaining a certain decentralization guarantees, certain performance across those shards and within each shard before really vertically optimizing the software implementation, right? Which is what vertical scaling often comes down to. How do you squeeze more out of the hardware through your software? Or do you just increase your hardware altogether? Frankly, we just feel like we're not there yet. We actually have the major protocol architecture issues to solve first. And then we'll go with the vertically scaled optimizations.
Yeah, I really think so too, because Solana provided a lot of throughput, but when you provide a lot of throughput and there's enough demand, it could be congested at some point. So you can definitely squeeze out performance from a platform, but at some point you need something that is linearly scalable. But the dynamic sharding, it means like linear scalability, right? It's what it's implying, right?
Yeah, and I think Solana is a really great use case. I mean, I also think we have to just step back. In some ways, maybe people have kind of lost the long-term vision here of what these blockchains are trying to do and what crypto stands for. But fundamentally, I believe the vast majority of the world's value and finance and money and market is going to run over these systems, right? Not a fraction of a fraction. And we're already seeing like the limitations of the most performant blockchains that we have designed to date, and seeing communities around. And again, I don't want to bash Solana because they've done like so much incredible work, and I really think they're pioneering an angle that has been neglected by some other community. But we're already seeing there's some demand for L2, right? And there's some demand for going modular, right? So if you look forward, down the adoption curve, like how are we going to solve those problems? And again, it comes back to leveraging horizontal scalability, leveraging sharding, which are the tried and true ways for global application in the traditional world to handle any sort of mass worldwide load. You look behind the scenes of Facebook, behind Google, behind even some of the financial product, you see sharding mechanisms and sharding architectures implemented.
Yeah, it is. It's a traditional way of problem solving in computer science too. Sharding has been done there in databases and everything. Whenever I read about Nil, it's not just sharding, it's zk-Sharding, like dynamic zk-Sharding, ultimately. So what is zk-Sharding? How is it different from the other protocols that it's focusing on sharding? Like, what is the zk angle here?
So I think you're making an important distinction, right? Nil is a horizontally scalable Ethereum L2 rollup, and it's made possible by zk-Sharding, right? And zk-Sharding is this combination of hybrid of sharding and zk technology. And what zk allows us to do is it allows us to have mathematical guarantees about the execution of computation on potentially adversarial machines. And this is an incredibly powerful tool for sharding, because one of the difficulties and one of the downsides to traditional sharding architectures is that you fragment the security. So in a traditional sharded architecture, we have a validator set, right? And let's think of this as an L1. We have a global validator set, which you essentially chunk into committees, and you assign each of those committees to a shard. So each shard has a number of validators assigned to it that's equivalent to the total global validator set divided by the number of shards, right? And this makes your sort of decentralization and censorship resistance guaranteed much, much weaker. Now, one solution to improving those qualities is to implement random sampling. And this is how I believe most sharded L1s do today, is they, every so often, I call it every epoch, they randomly sample and shuffle the committees or validators over the committees, and they reassign them to shards. And this random sampling, this random factor, introduced probabilistic guarantees that improve your decentralization and censorship resistance and security qualities. Now, we can go one step further with zk, in that with zk, we can have a single operator, single node, build block, and send with that block to other shards a proof. And this proof, this cryptographic proof, can, with utmost certainty, guarantee that the things that they process over their shard are correct. And this is a massive unlock that allows us to go really horizontal in our scale. And this is why zk is such a sort of powerful or magical technology for the world of blockchain and blockchain scalability. Now, I think it's really important to be honest, though, about where the state of zk is today, because right now there is an overhead. While it's much smaller, several orders of magnitude smaller than it once was, there's still an overhead that delays the proof generation by an order or two of magnitude. based off of the reference of execution, right? So when a validator processes the block, it may take them, say a second, but then the proof, may take, 10 minutes. And so what the ZK world is, spending a lot of time on today is, well, how can we shrink that proof generation time down, until we're almost at a point of like real-time validity proofs, and we can simply just couple every block that we build, every execution immediately with a proof and propagate it across the network. And this is exactly what sort of NIL is built for. But until we get there, we still need sharding. We still need the traditional sharding guarantees, right? We cannot just assume for that 10 minutes that a node is building blocks correctly. It creates far too much complexity and rollbacks. So in the interim, NIL runs a traditional sharded consensus over each shard. And so we have this decentralized, BFT algorithm where each block is being validated by all of the committee members. And then every n number of blocks, they generate a proof, attesting to the previous, n blocks that were built. And then the L2 piece comes in that every NIL shard generates blocks, generates a proof, sends the block root or a state commitment from the shard to a main shard along with the proof. And then the main shard verifies the entire network and aggregates them into a single proof. It then sends all of that information, including the full DA, so full state commitment from the entire network down to Ethereum. Ethereum can verify that the entire NIL network was ran properly in one single proof.
Okay. Got it. So they're like a one shard, like a beacon shard or the main shard, and they're like, it then there's n number of other shards.
Yeah, in our case, we call them the n number of shards. Those are execution shards. And those are responsible for processing transaction. The main shard the equivalent of the beacon chain or the beacon shard is our main shard. But really, the grandfather shard is Ethereum.
Ethereum,
right?
Yeah.
Right. Ethereum is the shard that is, the arbiter of truth that sort of, defines what is the, true state of the entire network. So we really think of it as just like, many shards around Ethereum, right? Ethereum is the center of our network.
Okay, cool. Like your background with from venture side, because there you have to have a very broad view of things happening in the space so that you can place your allocate your capital according to your thesis. If you look at the Ethereum layer 2 ecosystem, there is this Optimism has this Optimism super chain thesis. Their architecture, eventually the idea is like the super chain architecture. And lately Polygon came with this aggregation layer thesis. And NIL has this zk dynamic sharding thesis with your sharding architecture. If you look at like different teams trying to approach this problem from very different angles, could you like compare and contrast all these solutions, just to give your perspective on that?
Yeah, absolutely. And I think this is a question and answer that requires a lot of nuance, because I want to acknowledge that a lot of these systems, if you take a sort of bird's eye view snapshot, right, of a moment in time, all of them look very, very similar. Right? You have, many execution in sort of, environment, quote unquote, or node. Then you have some sort of, middle layer that is the, managing some sort of like consensus or shared consensus. And then you have, Ethereum as this base layer that's sort of, validating things and ensuring that things are done correctly and so on. So let's start with that, but we can kind of go down the list. With Optimism Superchain, I think it's yet to be seen if it's a legitimate thing. I know that they have an incredible team. As far as I can tell, though, there's no literature on the superchain, and for the most part, it's kind of this branded ecosystem of optimistic rollup. Now, one of the things that is frankly going to be a huge limitation for them is their use of fraud proof. And that's because fraud proofs introduce very poor user experience for communicating across environments, communicating across rollups or chains, just period, right? And actually, it was terrible for sharding too, right? In original sharding architectures, they used optimistic fraud proofs, right? In this optimistic setup, and this was very bad. How we had things like the fisherman dilemma. But coming back to the super chain, what that means is there is no trustless sort of communication across the OP rollup under the super chain unless they go zk, because you are always sort of at the mercy of this 7-day period, 7-day window for validating that whatever the optimistic rollup sent to this shared consensus layer to the base layer is correct. And there's really no other way for them to shrink that period without sort of, pushing against dangerous limit about their security, because it's based on pretty much just like game theoretic, economic, that, there'll be one honest actor who is not always incentivized, right? Who will step in within a 7-day period. So that, that's just something inherent to like fraud proof and the state of optimistic rollups. Then moving to, Polygon ag layer, right, where you have what looks very similar to a shared sequencer, with the sort of added functionality of validating or verifying validity proof. And this is will allow rollups to actually sort of communicate through the ag layer with one another, and allow for this sort of canonical ordering of multiple blocks from heterogeneous rollup, similar to a shared sequencer. But we come back to this issue of we don't have real-time validity proofs, and it's negligent to say that we do, right? We are, been in this world of zk before, and it's kind of like a harsh reality. I mean, we've come an incredibly long way in the field of zk, right? Like just at a blazing rate, but we do not real-time validity proof. So what that means is when you set up these sort of, in the case of like ag layer or even shared sequencers that work with zk rollups, what happens, the rollup node have to trust all other rollup nodes, because the ag layer or the shared sequencer layer, right, is naively assuming that blocks that are being sent from it are true, are valid. And then they're processing at times cross rollup transactions. And this is a very dangerous setup in a permissionless setting. So you either accept that a really dangerous, vulnerability surface or surface area, or you permission your set of rollups who can actually participate. And one of the issues with this latter route is, rollups need to scale further in order to keep applications on a single rollup that could lobby to be in one of these permission sets. Right now, a lot of these rollup are encouraging applications to spin up their own rollup. And this is actually, and the notion that these application-specific rollups can just simply be tied back in through these shared consensus layers is a farce. It's false, because you need to trust that now this application team who's running their own rollup is going to be an honest actor amongst all others. And so I think this becomes a very messy political game. When it comes now finally to zk-sharding and to what we're doing with now, we internalize all of that complexity into protocol engineering, not social dynamics, in that the protocol itself, the architecture itself from the get-go is meant to be able to do this scale up, right? And we don't have to, as an application, you don't have to lobby to be included within our, our consensus set, or, be lobbied to be included as a shard, right? You simply deploy your application to the network and nil handles the rest. And we think this is a user experience that, can really differentiate, nil, kind of in a sea of sort of fragmented roll-ups and political games.
Okay. And what stage is nil right now? Ethereum L2 space is like a very, very competitive, very crowded. It's getting crowded every week. There's one new rollup launching every second week. So it's a very crowded, very competitive space. What is the current status of nil, and like when will it be launching?
Yeah. The question on everybody's mind when I talk with them, they win with. So at nil, so we are anticipating a launch of a private DevNet later this summer. And this is, I don't think, something we've actually talked about publicly. So there's a little bit of alpha here that we're in this episode. And we want to work closely with some, really competent, quality, seasoned application developers. And the goal of that is actually to really work together hand in hand in defining and policing our user experience for some of the asynchronicity that our architecture introduces. Because this is, you talk to anybody who has gripes with sharding. Some folks, especially the, deep crypto folks talk about security, but a lot of them, the first thing that comes to mind is, you have this async, you have async calls, right? Now, there is, the reality, the internet is built on asynchronicity and these kinds of programming paradigms, but it is unusual for crypto. So anyway, if you're a seasoned application developer who's been interested in sharding, please reach out to me directly on Twitter. I would love to chat with you. And then, and I'm not going to give you a date, but we expect to have a mainnet in back half, hopefully, of winter. And we're really stoked the kind of application that we can bring over, and the type of builders who are really committed to like the long-term vision of crypto and blockchain, and share in this intuition and really just this insight, not so much an intuition, that we're going to need these types of sharded architectures in order to, you want to onboard the next billion users and have, meaningful economic activity happening over these networks. It's not going to happen in these single machine designs. It's got to happen over these horizontally scalable designs. And so we're really excited to work with developers to kind of, understand like that is the end state, right? And build for not just a year and in the bull market, but 10, 20, 30 years to come.
And from a performance perspective, you have like different benchmarks right now. Like you have an idea, or like when it launches and when someone launches an app, this is the performance that you anticipate from this platform. So from your performance, how does performance look on nil?
Yeah. So, I mean, we know a few things for certain, right? Block times are 1 second, 1 second, some sort of, so we do some fast finality. And so when you're from a user experience, things are very snappy. There's been this number of 6,000 TPS, right? Which, the TPS game is kind of, it's not great, right?
Yeah.
It's very overplayed, and it's just like marketing fluff. What's important to note here is, these massive numbers around TPS are a global TPS, right? So what is a total TPS that all of the shards together in aggregate are actually processing? Right, you can think of, each shard, right, in sort of a mental model as like a thread, right? And so you have, and it's very similar to like the parallelized execution, right? You're running all of these things in parallel. Now each shard at launch, our target is for a few hundred TPS, and that That's, I think, pretty modest, right? That's not the 10,000 TPS or thousands of TPS that, other folks are advertising. But when you zoom out and you look on aggregate at the network layer, right, we have many shards running at several hundred TPS. And we feel this is sufficient for what most people will need. Then the hard work and fun work of really juicing up the shards comes, right? And we will aggressively vertically scale each shard such that each shard is a Solana-like performant machine and had, I say, thousands and thousands, tens of thousands of transactions, right? Within a single shard. But, we'll do it only if we know that we have all of these other shards that we can run in parallel without breaking the system. And this is sort of the step-by-step process that we see towards working toward this end state, public blockchain.
So basically, when you transfer assets from one shard to another, from a user perspective, would you feel like a difference of like a inter-shard transfers or like intra-shard? Would there be like a UX?
Yeah, this is a great question. So there's a few ways. So yes, fundamentally, the naive implementation of intra-shard calls as additional latency, because you need each shard that is touching that transaction to actually sort of validate and process it, right? So let's just say we have 1 second block time, right? And there's, let's just call it like 400 milliseconds for networking overhead. Now we have minimum 2.4 seconds for a cross-shard call to take place. Now, that's the naive implementation. And there's a few things that we're working on that will sort of help this user experience. One is enshrine proposer builder separation, right? And what this will allow us to do is have these builders who are actually sort of maintaining and tracking data across multiple shards, submit transactions that are cross-shard in the same block to two different proposers on two different shards, right? And this allows us to actually sort of push the synchronicity of an atomicity of cross-shard transaction onto builders, and let us have sort of this 1 second, block time for a cross-shard transaction. The other is actually just, again, scaling each shard, right? Because the more throughput that we can handle through each shard, then the less cross-shard calls that, we potentially need to induce. And what we see is a lot of protocols, they're not necessarily calling each other, right? Protocols will be a collection of several smart contracts, but they're not always, say, communicating with one another, right? They're maybe communicating within their series of contracts. So one thing that we will have at launch, which will sort of help mitigate some of the asynchronous sort of overhead for a protocol, is contract co-location. So the ability to pretty much bucket several contracts together or group several contracts together and deploy them to a single shard where they will remain together persistently. And this sort of avoids any of the asynchronicity that the protocol itself or the application itself might, see if contract gets split across shard. There are optimizations that we can do at the networking level, right? We can, try and go sub 1 second block times, but these things are all marginal, right, compared to, to the other solution, which is just vertically scaling and boosting the processing of a single shard. Enshrine PBS to allow for sort of, submitting a cross-shard block across two shards at once, and the sort of contract co-location of application contract onto a single shard.
That means you could see like varying activity in a sense that you could see a really busy shards where the activities could be, there were like a hotspots of activity within the.
Totally. Yeah. And this is where the idea of like dynamic sharding becomes interesting.
Yeah.
Dynamic sharding is something that, for what it's worth, I think a lot of sharded blockchains have thought about, because one of the really cool things that you can do is you can begin to like load right your network based on the load that a particular shard is bearing, right? And if there's one contract on, say, shard A that's consuming most of the activity, you can actually split it out onto its own shard, right? And sort of like mitigate congestion fees by dynamically doing this at the protocol level. But this also introduces, other complexities, right? And I think for the most part, I don't believe, last I checked, any of these sharded blockchains do this.
Okay. That's pretty cool. Can't wait for this vision to go live. And we have some metrics to, I won't call it like the ideal metrics like TVL or daily active accounts. You have seen a lot of different protocols. Like, how difficult is in this market to come into the to the upper spots of the Ethereum layer to leaderboard? Like, we have leaderboard for everything. What are your strategies for that? How difficult would it be?
And this comes down though to like the community. It doesn't. It's not really. And NIL Foundation, as core contributors of NIL, we take a lot of onus and responsibility and like seeding and building out the community and working with the right early partners and making sure that application developers who are committed long term and aligned with how we kind of like see this end state playing out are getting what they need, right? And I think that's what it comes down to, is like, and I think that's what's attractive for a lot of builders is, hey, we're a new ecosystem. And that's a disadvantage because we don't have a distribution of users and we don't have an existing application ecosystem. But what we can offer is a commitment to our early adopters, right? In that we will commit to backing and supporting, your application development and growing your community, because that is the only way that we succeed. Is if the builders and contributors and community members that are, interested in and around what we're doing at a network level and a protocol level win. And so we're incredibly invested in making sure that those folks win. In the early days, it means, we're able to offer like really hands-on sort of service from, a developer relations perspective, from an engineering perspective, from a marketing perspective. And that's something that we want to hold through in perpetuity. So I think it comes down to treating people well, like, and understanding also like, we're not going to be everybody's like, slice of cake. Like, not everybody's going to love us, right? And that's okay. But there are going to be some people who do, right? And those people who do, I think, are going to be, just really rewarded in all kinds of ways, be part of that early adopter crowd. So, I think it's all about building that just like center of mass quality group of folks who, are here for the long run.
And community building is core, and you're here for the long-term vision. Blockchain space is like incredibly noisy space. It's hard to communicate. It's really hard, and just observing some protocols taking different approaches with that. And from your perspective, what are the difficulties that you find as a as a product builder in communicating this message to your user base or like the people, your target group?
Yeah. Like, noise, I think, is usually a consequence of folks being disingenuous. And that might be like a hot take, but, you see people away from the world of L2s, and let's just think about like crypto, trading and markets, right? People who are typically noisy are people who are shilling their back, right? And I think, that lens everybody needs to be aware of that, right? Like, not just, crypto is noisy and I should seek signal, but understand the root of where noise comes from. Because signal is actually, typically very highly correlated with truth and fact. right? And that's what makes Signal so interesting and valuable. You also have, folks who genuinely share their opinion, right? With no other motives but to engage in a honest conversation, right? And that is also Signal. And so I think, noise is this function of disingenuous, conversations or information. And for us, I mean, in a product perspective, it honestly feels really easy. It's just like, we're going to be just 100% genuine and honest about, our product and where it falls short in certain areas and where we're sort of dedicating, time to improve. We're going to be honest about timeline. We're going to be honest about, the way that we treat people and, allocate our resources. So it's almost like the market has, like, for a new actor, right? Because once you go the noisy route, once you kind of like fall down this route of, you have these sort of perverse incentives that, hinder your ability to just be genuine within the market. We're in like this great position to kind of just say, okay, well, we're just like going to do the right thing. And, we're going to be here as hopefully a beacon of signal for technology and the products that we're building, and also a beacon of signal. And when it comes to sharing our opinion, right? I, for one, I think all of the blockchain that are trying to scale hope all of them succeed in their own right, right? I have my own opinion about what the end state should look like. And I feel very strongly about that, but I don't want to just force that on others. I want to have a conversation about, well, what can I learn from you, right? And what can you learn from me? And I think that's, how we end up achieving, anybody's vision of what an end state for blockchains are.
That's perfect, because sometimes it's really like looking from a retail perspective, looking through like Twitter timeline, or sometimes really hard to separate. Yeah.
Man, I see the same shit, like I'm on Twitter like all the time. I mean, a lot less now than I was, back when I was investing, but there's a lot of shit out there, like the shit. And it's and I think it's also like it's really, I think it's really on the onus of projects and those with influence and reach to just like commit themselves to being, upstanding certain values in this market of, integrity and transparency and honesty, right? And, not letting the price kind of cloud your vision, and, and everybody it will do it, I'll probably do it too. Like, there'll be a time where I'm just like really shilling nil, because that's where I dedicated my time, right? And my energy. But I think, you kind of have to have that, like that maturity of just, okay, right? Like, let's zoom out, like, let's take off the rose colored lenses, right? We're all here for the same purposes. Let's be genuine, let's be honest, engage in, intellectually sound conversations and not just, these chilly marketing, whatever you want to call it.
Cool. I think that's a great place to end the conversation, and we covered a lot, and it's went through all the major topic, and thank you for the fantastic conversation that you offered. And looking forward to the upcoming developments for NIL, and hopefully it will be a great success, and looking forward to that.
I appreciate the kind words, Suraj, and thanks for having me on and letting me talk a bit of my book, so to speak. But also really great questions, and I'm happy to come back hopefully sometime soon.
Yeah, looking forward to that. Thanks for tuning in. If you are keen on getting deeper insights about Web3 tech, our newsletter, Just the Metrics, is just what you need. It's packed with valuable information, and it's completely free. You can subscribe by clicking the link in the video description. It's a great way to keep up with the latest in the Web3 space straight to your inbox. And before you go, please hit that like button, and don't forget to subscribe to our channel for more updates and insights. Your support is what keeps these videos coming. So see you in the next video.